Beneath the vast oceans, hidden webs of fiber optic cables stretches for hundreds of thousands of miles, forming the unseen backbone of the internet. These cables carry almost all the world's data, transmitting information at the speed of light. But with the increasing use of AI and video streaming, the demand for data is skyrocketing, and a single fiber optic strand can only carry so much data. So how do tech companies squeeze more and more data through these undersea highways? The answer lies in groundbreaking technology called DWDM, dense wavelength division multiplexing. This powerful innovation allows a single fiber to carry not just one stream of data, but dozens or even hundreds of data streams simultaneously, each traveling on its own unique wavelength of light. This is like turning a single-lane road into a multi-lane highway, exponentially increasing capacity without laying new cables. The first direct communication between continents was by telegraph. In 1858, the first transatlantic telegraph cable was laid between Ireland and Newfoundland, Canada, but this cable failed only after 3 weeks. Success came in 1866, linking Europe and North America. It took 14 days, 1,852 miles of cable at the bottom of the ocean to connect the continents. Britain expanded the telegraph network, connecting India in 1870 and Australia in 1872. By the 1950s, the telegraph was making way for the more convenient telephone. The first submarine telephone cable, TAT-1, was laid in 1956. It could carry 36 simultaneous calls between Scotland and Newfoundland, Canada, marking a leap in reliability and capacity. TAT-1 cost $350 million in today's money. By the 1980s, the coming of the internet and the digital age demanded higher speeds. In 1988, TAT-8 became the first transatlantic cable to utilize fiber optic technology, employing light pulses and digital repeaters to handle 40,000 calls at the same time. But with the upcoming of multimedia on websites, YouTube videos, online video games, and other data-hungry apps, even more data capacity between continents was required. But building more and more submarine cables would just be too expensive. So engineers needed to find a way to push more information through each submarine cable. Enter the concept of splitting wavelengths of light and technologies of TDM, CWDM, and DWDM. The visible light that we see from the sun can be split into various colors. Each of these colors of light have their own wavelengths on the electromagnetic spectrum. The solution engineers found was to split the light entering a single fiber into dozens of wavelengths, each carrying its own data stream. Fiber optic cables are made of super thin strands of glass or plastics wrapped in protective layers. Data is converted into pulses of light that bounce through the fiber optic cable via a phenomenon called total internal reflection. And unlike electrons traveling through copper cables, light traveling through fiber optic cables maintains its strength remarkably well, even across thousands of miles. The first of the light wave splitting technologies was the TDM, time division multiplexing. TDM divides the capacity of single fiber into time slots. This was the leading technology in the telecom sector from the 1960s through to the 1980s. Wavelength division multiplexing, WDM, emerged in the 1970s. It utilized 2 to 8 light wavelengths in a fiber to transmit data, but didn't quite meet the density requirements. A simplified variant, coarse wavelength division multiplexing, CWDM, was introduced as well, featuring wider channel spacing for short-distance networks like rail metro systems. But more data speeds was required, and so in the early 1990s, the dense wavelength division multiplexing, DWDM, was born. DWDM is a fiber optic transmission technology that combines multiple data-carrying light wavelengths onto a single optical fiber. Every wavelength acts like its own channel, allowing for huge data capacities across long distances. Think of it like a road that has been turned into a multi-lane highway where each lane carries its own traffic smoothly without any interference. The folks at Bell Labs and Nippon Telegraph and Telephone were the pioneers of DWDM technology. In 1996, Ciena Corporation launched the first commercial DWDM system for Sprint's long-distance network. Now defunct companies, Lucent Technologies, which was spun off from AT&T Bell Labs, and Canadian company Nortel were also key players in the DWDM scene in the 1990s. Today, DWDM forms the spine of the internet by multiplying the capacity of existing fiber optic cables. With DWDM, hundreds of data streams can coexist in a single fiber cable, enabling terabits per second speeds. The advancements in technologies have lessened the need to install more fiber cables, which cuts costs and reduces the need for physical infrastructure. It has made streaming, cloud computing, and real-time services possible by moving large amounts of data across countries and oceans. DWDM has multiplied capacity on existing fibers by almost 1,000 times. Besides its role in connecting continents, DWDM is also used in other high-bandwidth applications. They are used in telecom backbone networks. Mobile telecom carriers like AT&T, Verizon, and China Mobile use DWDMs to transmit terabits of data across country, connecting their regional hubs by fiber. It's used in their 5G networks to support the massive bandwidth demands of moving data between big cities and across country. Another use case of DWDMs is in the data center. DWDMs are used by cloud providers like Amazon AWS or Google Cloud for data center interconnects, linking together their data centers over long distances. Interconnects are necessary because they help synchronize data across data centers to move compute loads dynamically to balance workloads for backup, disaster recovery, and for geo-redundancy. With the explosion of AI, demand for interconnects is rising further. AI workloads often run across multiple data centers, driving the need for higher capacity optical connections. Lastly, DWDMs are used in metropolitan networks. A metro network typically covers a city or a metro region, 80 to 120 kilometer area. They aggregate traffic from local enterprise and 5G access sites into a core or regional hub. Rail communication systems require large data transmission capacities for automated signaling and real-time control of metro system. The data capacities are also used for train-to-ground communication, video surveillance, remote monitoring, and smart ticketing. Metro networks also include high-capacity fiber optic networks that connect cities and regions, linking access networks to core networks. DWDM systems are made of several key components including transceivers, which convert electrical signals to optical signals, multiplexers and demultiplexers, which combine or split wavelengths, tunable lasers, which generate the precise wavelengths, optical fibers, which transmit the light signals, optical amplifiers, which boost signal strength over long distances, and filters and switches, which manage wavelength routing. DWDM systems are classified by their channel count, reach, or application. DWDMs can be classified by their channel capacity. 40 channels are older systems with 100 GHz spacing, 80 channels are modern systems with 50 GHz spacing, and 160 channels are ultra-modern, ultra-dense systems. DWDMs are also classified by their reach, whether long-haul DWDMs or metro DWDMs. Long-haul DWDMs connect continents. They are transoceanic or cross-country for distances of more than 1,000 kilometers. Metro DWDMs focus on transferring data over shorter distances, less than 100 kilometers for city and regional networks. The American company Ciena Corporation was the first to introduce a commercial DWDM. It was founded in 1992 as Sterlite in Hanover, Maryland, and rebranded to Ciena in 1994. It has since grown into a global leader in optical and packet networking technologies. In 2010, it acquired Nortel's Metro Ethernet Networks division, expanding its optical portfolio. In the 2020s, it pioneered 800G coherent optics DWDM, driving the next generation cloud and 5G infrastructure. Ciena holds about 25% of the American optical networking market, serving major carriers like Verizon and AT&T and data center giants like Google and Microsoft. Globally, it commands about 15% of the optical equipment market, third behind Huawei and Nokia, facing pricing pressure from Chinese rivals like Huawei and ZTE. It benefits from Western distrust of Huawei and operates in 60-plus countries with strongholds in North America, Europe, India, Japan, and Australia. Global clients include UK's BT Group, Telstra of Australia, and Reliance Jio of India. Ciena designs and manufactures switches, routers, Ethernet, submarine, and undersea cables. Its top-of-the-line DWDM is called the 6500 series. The Finnish company Nokia is the most successful Western company in the DWDM business. After losing its smartphone business in the late 2000s to Apple's iPhones and Samsung's Galaxies, Nokia in 2013 sold its smartphone business to Microsoft and turned its focus on telecoms and networking equipment like base stations and DWDMs. In 2025, Nokia bought the US-based Infinera Corporation, which itself had earlier in 2019 swallowed German-based Coriant. Coriant, created in 2013 through mergers of Siemens Networks division, Sycamore Networks, and Telelabs, was later acquired by Infinera in 2018. After the acquisition, Coriant's brand was phased out and its operations were absorbed into Infinera. Infinera was founded in the year 2000 and is headquartered in San Jose, California. In the 2020s, Infinera led advancement in 800G transmission, critical for cloud and 5G growth. With the purchase of Infinera in 2025, Nokia now holds 15% of the American optical networking market, serving Tier 1 carriers like AT&T, Verizon, and cloud providers like Google and Microsoft Azure. In Europe, it holds about 15% share in optical networking, serving telecom giants like Deutsche Telekom, Vodafone, and Orange. Globally, it operates in about 100+ countries and commands about a 10% share, competing with the likes of Huawei and Ciena. Its key markets include Europe, America, Asia Pacific, and Africa. With mergers and acquisition, Nokia has now the skill and technology to handle pressure from low-cost rivals like Huawei and established players like Ciena. Nokia's DWDM is called the 1830 Photonic Service Switch, supporting long-haul, metro, and subsea networks. Huawei Technologies is the biggest of the Chinese equipment providers. Headquartered in Shenzhen, China, it was founded in 1987 as a privately held company owned primarily by its employees through a unique stock-sharing model. But despite its private status, it faces global scrutiny over perceived ties to the Chinese government. Huawei began by manufacturing phone switches. It expanded globally in the 2000s with telecom equipment like base stations. By 2010s, it had begun to dominate 5G patents and infrastructure. In 2019, US sanctions crippled its smartphone business with chip restrictions and software bans. Market share fell by 18% in 2019 to about 4% by 2023. The Americans labeled them a security threat and convinced their allies from Europe, Australia, and Japan to ditch all Huawei telecoms equipment as a precaution from Chinese spying through backdoors in Huawei equipment. But even after all that, Huawei rebounded and is now the world's largest telecoms equipment vendor, a global tech titan that produces not only telecoms infrastructure like 4G, 5G equipment, optical networks, base stations, but also smartphones, laptops, semiconductor carrying AI chips, and now even cars. Huawei today innovates aggressively in semiconductor chips, 6G technologies, AI, and EV cars to offset sanctions. It commands about 35% of the global telecoms infrastructure market and leads in 5G deployment. It operates in more than 170 countries, mainly Belt and Road nations, with strongholds in Asia, Africa, and Latin America. Its DWDM is the Optics OSN 1800 OTN platform used for metro, subsea, and backbone networks. ZTE Corporation is the second biggest Chinese telecom supplier. It is a state-owned company founded in 1985, headquartered in Shenzhen, China. It expanded globally in the 2000s, becoming Huawei's biggest competitor from China. In 2018, it faced US sanctions for violating Iran-North Korea trade restrictions, resulting in a $1.4 billion fine. Like Huawei, it is also known for a wide range of products including smartphones, 5G telecoms base stations, etc. In China, it holds about 10% of the telecoms infrastructure market, trailing Huawei's 30%. It is also a minor player in smartphones with about 5% share against giants like Xiaomi and Oppo. Globally, it has a market share of about 10% in the telecoms infrastructure, fourth globally after Huawei, Ericsson, and Nokia. It operates in about 160 countries with strongholds in Asia, Africa, Europe, and Latin America. Its key DWDM product is the CXZone 8000 series for ultra-high capacity fiber transmission. Headquartered in Wuhan, China, FiberHome is another Chinese state-backed company with expertise in telecom networking and 5G-ready solutions. It pioneered China's first optical fiber in 1982 and became an integral part of connecting China. Founded in 1974 as a research institute, FiberHome evolved into a telecoms giant, driving China's optical network expansion. Today, it competes with Huawei and ZTE in domestic and global markets. Key projects include the P submarine cable connecting Asia to Africa and Europe. FiberHome designs and manufactures telecom systems like base stations, fiber optic cables, and DWDMs. It has presence in more than 50 countries around the world, positioning itself as a cost-effective alternative to Western vendors in emerging markets. In China, it holds about 20% share in optical networking, supplying major carriers like China Mobile and China Telecom. It exports to about 100+ countries, focusing on Asian countries like Pakistan, Indonesia, African countries like Nigeria, Kenya, Latin American countries like Brazil, Peru, and a few European countries. Globally, it competes with Huawei, Nokia, and Ciena, but holds a smaller market share, about 5% in optical systems. Its key DWDM product is the Phones series for long-haul and metro networks. In the late 2000s, after having been late for the 3G and 4G mobile revolutions, India wanted to be at the forefront of the upcoming 5G mobile revolution and bring fast internet to its more than 1 billion population. But they also wanted to do that using Indian technology and Indian equipment. BharatNet was the world's largest rural broadband project, using DWDM to connect 300,000 villages in India from 2013 to 2017. The Indian government employed CDOT, the Research Center for Development of Telematics, to develop telecoms equipment including DWDMs for the project. The United Telecoms Limited, a local Indian telecoms company, was selected to manufacture the DWDM equipment. CDOT is also reported to have signed technology transfer agreements with other Indian manufacturers like Indian Telecom Industries Limited, Tejas Networks, and Sterlite Technologies. The Indian government's gambit was a huge success. It helped the country connect more than 1 billion people to fast internet, while also helping build a local telecoms industry. While Indian firms are not yet global leaders like Huawei, Nokia, or Ciena, they play a significant role in their domestic telecoms infrastructure market and are expanding internationally. United Telecoms Limited is a privately held Indian telecoms and infrastructure company. Founded in 1991, it is headquartered in Bangalore, India. While it faced financial distress in the late 2010s, it has since restructured operations and is now a healthy company. UTL was helped by the Indian government when it was chosen for the deployment of a 50,000 kilometer optical fiber under the BharatNet Phase 2 project. Strategic tie-ups with state-owned telecoms provider BSNL to provide 5G-ready infrastructure for rural 5G rollout also helped the company regain its foothold in the Indian market. It also now has contracts with private ISPs to expand fiber networks in underserved regions and holds about 5% market share in Indian government telecoms contracts. Locally, it competes with the likes of Sterlite Technologies, Tejas Networks, and HFCL. UTL's DWDM is labeled DWDM 100G OTN MSPP. Tejas Networks is a Tata Group company that offers end-to-end products and solutions for fiber broadband, 4G, 5G, DWDM, OTN, switching and routing networks. Headquartered in Bangalore, India, Tejas Networks is a leading telecoms equipment manufacturer. Acquired by Tata in 2021 through its subsidiary Panatone Fininvest, it operates under the Tata Group's umbrella, manufacturing telecoms infrastructure products like fiber optic cables, 5G radio units, switches, routers, and DWDMs. Founded in 1998 by Indian engineers, Tejas became a public company in 2017. It gained prominence through partnerships with Indian telecom giants like BSNL, Reliance Jio, and Bharti Airtel, supporting critical projects like BharatNet. The company exports to about 75 countries across Asia, Africa, Middle East, and Latin America, focusing on emerging markets with cost-sensitive needs. Tejas Networks' DWDM product is the TJ1600 series for metro, long-haul, and submarine networks. Russia also has companies that create DWDMs. T8 was created in 2008 as a startup by graduates of the Moscow Institute of Physics and Technology in the Skolkovo Business Incubator. Today, T8 dominates Russia's DWDM market, deploying over 100,000 kilometers of fiber networks and offering products for backbone networks, metropolitan networks, and data center interconnects. They have been involved in the construction of backbone fiber networks in Siberia, St. Petersburg, and the Volga regions. T8 occupies about 45% of Russian DWDM market, competing mainly with Chinese companies. Among its customers are the largest telecoms operators like Rostelecom and mobile operators like MTS, Beeline, Megaphone, and Tele2. The company has also implemented projects in neighboring countries like installing DWDMs and optical amplifiers in Kazakhstan. Other notable Russian DWDM companies include VPG LaseOne, Neoros, and Supertel. VPG LaseOne offers a 600 GB per second wavelength device called Horizon, while Neoros brings the NR1008 DWDM platform, also featuring 600 GB per second per wavelength, ideal for both metro area and long-haul networks. Supertel's DWDM is called the OptiPack 2. DWDM technology has been fully democratized. The global leaders are Huawei, Nokia, and Ciena. Indian companies focus on cost-effective localized solutions for regional networks and government use cases. The Russian company T8 is catering to fight for dominance against the Chinese in the Russian market while seeking leadership in Central Asia and former Soviet bloc countries. DWDMs come with special features. Let's explain some of these features. ROAD-M stands for Reconfigurable Optical Add-Drop Multiplexer. This feature allows wavelengths to be added, dropped, or routed on-site, making the system more reconfigurable and enabling network operators to remotely provision network traffic. FlexGrid. This feature enables variable channel spacing of wavelengths for more efficient spectrum use. FlexGrid is now mandatory for 800G and 1.6 TB networks. Proprietary DSP chips. Some DWDMs are powered by in-house designed custom chips that facilitate higher transmission speeds. Ciena's exclusive digital signal processor chipset is called the WaveLogic DSP. Nokia's is the PSE6 and Huawei is ODSP. IP over DWDM. IP over DWDM integrates IP routing within the optical layer. Ciena calls its version adaptive IP, with Huawei calling its version OptiTrans OTN switching. Comparing DWDMs from public information is difficult, but units from Huawei, Ciena, Nokia, T8, and ZTE all seem to have top wavelength capacity of 800 GB per second per wavelength. The units from China's FiberHome and Indian manufacturers Tejas and UTL have less wavelength capacities at 400 GB per second. Huawei has a model with the highest number of channels at 120, and the rest of the companies have units of up to 96 channels. The maximum throughput for units of Ciena, Huawei, T8, ZTE is around 38.4 terabits per second. Most operators seem to regard Huawei and Ciena's offering the best balance between capacity and programmability, while Nokia provides the most flexibility and reconfigurability. DWDM sits at the foundation of today's networks. It powers the physical layer that carries all the data for upper layer protocols like IP, Ethernet, and OTN. By enabling terabit scale data transport over existing fibers, it ensures seamless connectivity to everything from telecom operators to global cloud service providers. DWDM allowed internet to grow exponentially without the need for constant digging for new fiber lines. Today, DWDM systems underpin AI searches, 8K video streaming, and virtual reality by delivering petabit level capacity. The first DWDMs that appeared in the 1990s transferred up to 1 terabit per second. The 2010s with coherent optics transferred 20 terabits per second per fiber, and the 2020s with special division multiplexing SDM is transferring about 100 terabits per second per fiber. Ciena will soon be introducing the next generation of DWDMs, moving from 800G to 1.6 terabits per second per wavelength. A new company, Mavel, has introduced a 3nm Mavel Ayar chip that supports 1.6 terabits per second, offering higher performance whilst reducing power consumption. In the near future, companies like Ayar Labs with optical I/O chips are merging photonics and semiconductors to offload some of the functions of photonic processors, thus increasing speed. Intel is also creating silicon photonic transceivers by integrating CMOS with photonic integrated circuits. DWDM will remain the backbone of global connectivity, evolving with innovations like photonic integrated circuits and machine learning-driven network optimization. Its creation marked a turning point in telecommunications, making the modern internet economically and technically feasible. Subscribe and stay tuned.